Hello YouTube world, this is Logic Crazy and I'm Jonathan, and in this tutorial we're going to be working on our n-Queens solver tutorial series, but specifically we will be focusing in on HashMaps. So for any of you who are watching this tutorial and don't care or maybe don't even know what an n-Queens problem is, feel free to watch it just for the HashMap part of this. The very last part of this tutorial I will be focusing on n-Queens, but before then, let's get started with HashMaps. To explain first what HashMaps are, I've said in the past that they're sort of like an array that can be ginormously huge and that have a few extra perks. Now, you may not have heard of HashMaps, but perhaps you've heard of hash tables. And they're pretty much the same thing. Technically they aren't, but basically there's just a few minor details. If you understand one, you'll pretty much understand the other. There's a couple differences between, such as synchronizing between multiple threads and a few other complicated things, but really this tutorial should apply pretty well to both sides, at least to give you a gist of both sides. So we won't be doing anything terribly complicated here, but it should set the foundations for this. So basically, when do you first need to use a hash map? I guess we should ask. And the times you need a hash map is, for instance, let's say I have an array. So I have this set of data, all these items, and I have to just list them, at index 0, 1, 2, 3, 4, 5, and put a value according to each spot on my array. Now, of course, we're talking about one-dimensional arrays and one-dimensional hash maps. So we create this big list, and then I can go to item 1 and find out the corresponding value. But if I wanted to not only to store, let's say, an address, instead of just having to have that index as 0 or 1 or 2, what if I wanted it to be index extravagant, and then as the value for the extravagant index, it should say how many vowels are in the word extravagant, and then I could have another spot. So instead of numbers, I'm using words. And then in the hello spot on my array, then it would have the number of vowels in the as the value would be the number of values in the word hello. So that would be an example of something a hash map could do. Another thing is it can handle an incredibly large amount of data, as in thousands of items, and you don't have to worry about the array getting too big and taking up space and slowing down and such near as quick. Another thing is, when I mentioned that you can use words or anything, you don't have to just label them 0, 1, 2, 3, 4, 5, 6, 7. That also means that you could use numbers, but go 1 or 2, 4, 6, 8, 10, and skip different items. You don't have to use, for instance, if I only want to use odd numbers, then instead, or even numbers, let's say, instead of having a table or an array that was 10 in length to fulfill the numbers 0, 2, 4, 6, 8, 10, I can just have a smaller hash map that only includes the values 2, 4, 6, 8, 10, and not have those filler empty values that we know we will never use. So these are some examples of why hash maps are so useful. And there are many other reasons, but I'm not going to go into them right now. Feel free to research them at your own pleasure. So let's get started. I've started out with a bit of an example here. So I've created a class called HashMap or HMap, and don't feel you need to write this down, but just look at it as a bit of an introduction to the way things could work. So I have a main method right here, and it calls map filler, and then map recaller, and then it says example completed. So let's start off with looking at this map filler. So this map filler is just this short little piece of code here. Most of it is this massive array in the middle. So what it does is it has this loop. It goes through, I believe, yes, 1 million times it goes through this loop. So just a bunch of times. I'm trying to generate a big hash map. So 1 million times over, it creates this array. Now I should, if I want to speed this up, create the array outside of the for loop, but we're not too worried about speed here. So I create this array, and this is a valid n-queens problem for those who are interested of an 8x8. But anyways, just for now, suffice to say that it is an array. And what we want to do is create a hash map, but instead of having, for an array, you would have indexes 0, 1, 2, 3, and then a corresponding value. So at index 3, the value is 7 on the array. But in a hash map, like I said, you don't need numbers, or you don't need to be consecutive numbers. So you can say, we call it a key. And in this case, it can be a bunch of text. It could be, like I said, the hello key. So that's sort of like your index hello instead of a number, index 0. So we have an index, which in this case I've called text plus I. So text 1, text 2, text 3, depending on where it is in this for loop. I will change. And instead of storing just a regular value, I've decided to store this string. And basically the string is taking one of these rows and converting them into a text string and storing them into this location, this key on the hash map. So when it first runs here, it will set I to 0. I will just demonstrate this here. Basically what I will do is the code stops, has run all the way up to here, comes to this green line, and says place, now I is 0 currently, text 0 is what it will be, and this array looks like this. So brackets and a Q, it happens to be the first row here. What I will do, let me see. There we go. Now what we will do is we'll look at the watch, and we'll see there's a key 0, but it's text 0. You can see this right over here. Let me just move this over. Here we can see we have sort of an index, but we call it a key in HashMaps. Text 0 has this value associated with it. So the key is text 0, and the associated value is this string here. Now when I run this again, we have a second one. Now we have another key, now it's text 1, with the next line associated with it, and so on and so forth. Right down to a million of these. Now, so when we want to store a spot, we use this word put. So we say main map, which is a hash map that I've already created, as written here, static hash map, and I give it a name, main map equals new hash map. So it's a static map, and what you do is say dot put, and you indicate the key and the associated value. And then let's focus on how we recall it. So what I have done is created a simple setup. So I'll go through it a million times, and it'll say, please enter a key. It is now running in this map recaller method here. So it asks for a key, and it says, it checks if the map contains a specific key. So let's try a certain key. Let's first check what's the format of these keys. The key will be text and then a number. So let's not do the text. Let's say hello 15. And it says this is an invalid key. There is no such key because main map does not contain key. Now I've just copied the code again, and it'll do the same thing, but this time I'll put in something valid. Now I have to make sure I got the capitals right. All right. Text 15. Now when I hit enter, it gives me the appropriate line. And this line is the bottom line of this array, which is correct because 15 modulus 8 turns out to 7, and that is the 7th row. So that is perfect. Now we're doing the opposite. In an array, we can just say, here, call out an index, and I'll tell you what the value is. But with HashMaps, I can check, does a specific value exist inside the map? And so it would be like taking an array of index 0 to 100 with multiple words, let's say of a dictionary, starting with all the A's, and saying, does the word banana, is it anywhere in this array? And the answer would be no if it only contained letters starting with the letter A. So it's a really fast way of searching. In an array, you have to pretty much just do a for loop and say, check index 0, check index 1, check index 2, check index 3, and do it very manually. It's very slow, but HashMaps, they've really done a good job of making it very, very fast and efficient to say, is there this value that has been associated with a specific key, and it will return true or false. It won't provide the key specifically, though, because there could be multiple keys that all contain the same value. So this value may have occurred multiple times in the map. It won't let you know how many times. It's just saying it's occurred at least once in this map. So let's enter a value. Obviously, this is a valid value right here because it knows it contains it. But let's add in a few gibberish letters there, and it will say this is an invalid value. Now I've duplicated the text again, so we'll go through the same code with the actual line, and now it says this is a valid value, and the example is complete. So that is a basic quick overview. Hopefully that wasn't too quick or too boring, but this is how HashMaps work, and I've also provided some basic ideas on why HashMaps are so valuable, and they're especially valuable in creating chess engines and such like that.